reporting to you from the
Fort Gratiot Middle School, where we're having the third annual CO2 Race Car Challenge. I've had the pleasure to be a judge, and I'd like to introduce to you two of the other judges.
Good morning. I am John Wunsch from St. Clair Tech. I'm a school work coordinator over there for this last year, but for 21 years I taught auto mechanics over there.
Good morning. I'm Andy Pocadello, retired principal from Chippewa Middle School. I had been an industrial arts teacher at Chippewa early in my career, and I was pleased to be invited to this program today.
Thank you, gentlemen. Was this a difficult task?
Oh, extremely difficult. We were under a lot of stress because there were so many unique cars here with a lot of effort put forth by all these students. I know they spent several weeks in their design and their carving and formation of the car, along with the finish and the paint, and a lot of different operations were put into this project.
Thank you, Andy. John, how did you feel about that?
I agree with Andy 100% on what he said. The beauty of this was the students really didn't have any strict guidelines. They let their minds go and be very creative, and that makes it that much harder to judge. Like most unique vehicle, whose mind is unique, and it's been very challenging and a lot of fun, and I could see this growing into more than just this school system here.
Well, thank you, gentlemen. I can attest to the fact that it was a very difficult chore to come up with the winners, but interestingly enough, the winners on nearly every scorecard really came to the top, and we were able to come to a consideration and conclusion in regards to who the winners will be. Behind you, you can see the trophies, and they will be awarded at the end of the competition, and we're looking forward to that exciting part of the event. We have with us a parent who has come over to watch. He has a son involved in this competition, and your name is, sir?
Michael Lee, and my son's Edward Lee from Chippewa. Mr. Warren's the shop teacher out there, and he's done an excellent job, I thought, motivating these kids and getting at it. And I know my son's enjoyed it because he makes me take him in early to work on it. So I think it's a real good program, and I think it's a lot of fun for the kids.
Mike, I know that you've done a lot of work behind the scenes, and you're the host instructor, as well as Fort Gratiot is the host school today. Could you give us a little bit of the history of the CO2 Race Car Challenge from the industrial arts technology perspective?
We've actually been doing this for about 3 years now. And the first race took place at Port Huron Central. The second year race took place at Chippewa. And the race this year, the third race, is taking place at Fort Gratiot. We are currently the hosts. Basically, the CO2 car competition started with a research and design project. And what we're actually doing here is teaching our students how to do some research and do some brainstorming and come up with a solution to the problem. This particular design problem is to design something with 4 wheels that accepts a CO2 cartridge reaction engine, and that goes so fast you can hardly see it when it takes off. We do a lot of background work on this. Before they actually design a car, we first of all run a series of movies that give them an overall view of what they're going to design. So basically we're creating a vision on what we're expecting them to do. Later on, we fill in the details. We have them do reports on aerodynamics. We also have them do research on other cars that have already been built, so that they can come up with a more improved design. After we cover aerodynamics, then we talk about the design limitations. Most of these cars are designed within certain design limitations. For instance, they are supposed to be at least 8 inches long. If they're any shorter than 8 inches long, then they are not within the design envelope. They also have 1 3/8 inch for the maximum width that they, or minimum width, excuse me, that they can be. Anything less than that would become inherently unstable. They also have a design limitation of, if you have the narrowest part of the car must be at least 3/8 of an inch in diameter. Anything smaller than that. Now that's the combined cross-sectional area. If they're building something that has the shell effect, where the wheels are in the inside, The skin can be a lot smaller because the combined cross-sectional area will still be at least 1/8 of an inch. And tubular construction is much stronger than using a beam-type construction. After we go through the basic design principles, then we go through your basic, what we would call a geometric construction. In order to actually draw the car, you must be able to use some simple drawing instruments such as a French curve, a compass, straight edge, and a scale, and so forth. After we teach them how to use these instruments, then we do some brainstorming. In order to come up with any design, you must come up with many, many different possible solutions. Generally, what we will do is put down all our ideas, no matter how ridiculous they may seem at the time. Between 15 and 20 different sketches. We call these thumbnail sketches, or brainstorming sketches. Finally, we will come up with 4 sketches that will be an improved version of the brainstorming sketches. In other words, we'll do a little bit of evaluation on our thumbnail, so we have 4 different design possibilities. Finally, we will come up with a final design. That final design must have a top view and a profile view. The top view will show it from the top, the profile view will show it from the side. It must be made to scale, because eventually that design will be cut out and it will be taped to a piece of wood and traced to 2 sides of the piece of wood, either the top and the side or the bottom and the side. Eventually then it will be roughed out on the bandsaw. Then they will reestablish their center lines on the actual car itself, and then they will start their model. Generally speaking, they will square the car up to size first so that they have all the major dimensions taken care of, so it's squared to size. And then they will round it using a file with special jigs and fixtures so that they get it rounded to the exact size that they want the car to be, actually slightly larger. After that, then they go through an extensive sanding operation where they start out with a coarse grit to take away any file marks. Then they will get into a finer grit. Finally, they will finish up with a 180 sandpaper, and then they will prime the car. We must use at least 2 to 3 or 4 coats of primer, sanding with 400 between each coat. We supply the primer, they come up with their paint. And the reason why we let them pick their paint so they can come up with the most creative paint job that they could possibly come up with. They're allowed to put pinstriping on it, decals, their own artwork, whatever, by the time they're done. Finally, once they have that part done, then they will put the screw eyes in, and if there's any bearings to be made, they will come up with their own design for bearings if they decide to be creative on that aspect of the design, which will cut down on the friction. Eventually, they will come up with their own creative solution for a lubricant, and they may use anything that they want to lubricate the axles. And of course, finally, we will have the race, which is basically the test of the design. One thing, though, that you must know, this is not a process that is all done by the time you're finished on the drawing board. There are many design, you might say, modifications that take place after the drawing board. Just because it's perfect on paper does not mean it's a perfect design. In industry, even though we may have a product that may come out on a production line, we may find out that we may have to change it after we start production. And so the students are allowed even to modify their design after they've come up with a final solution. Also, too, we find that sometimes that some of the things that they're trying to do does not work. We don't look at that in terms of a failure. They just found a way it wouldn't work, and that's actually helps them come closer to a final solution. One of my students this year actually built a car, finished it, and decided that he had a better solution later. And I says, well, do you have enough time to finish your car before the race? And he says, yes, I will make sure it is finished. A week and a half later, he came up with this real go-fast design. He learned a lot from his first design, which helped him to come up with an incredible second design. And he did extremely well. He was right up there with the last 3 at the very end. And he did an excellent job.
Mike, from your presentation, I can tell that you used a lot of math and science terms, and you mentioned creativity from the fine arts venue. Is this true that you see a lot of math and science being taught in your class?
Definitely. Has a lot to do with math and science. Momentum's part of it, friction's part of it, aerodynamics. You have to consider the weight or mass of it. Remember that if you have a higher, if it's heavier, it's going to take more energy to move it down the track. They will also have to learn that there are certain design trade-offs. The trade-offs are you might have a car that may be a little heavier, but it's more aerodynamic. Or you may decide, well, wait a minute, I want it to be a little lighter, so you may sacrifice part of your aerodynamics for the weight. Also, the length of the wheelbase. If a car is a little longer, it's going to weigh a little bit more, even though it may go straighter down the track. So basically what you're doing, you're creating a recipe. Even though you have the same ingredients, you're going to change the values of each one of those ingredients. There is no right or wrong way. There are many different right answers.
Good.
There's not just one right answer.
Mike, how has this changed the way you teach? Has it been more exciting for you? Have you got more class interaction?
It has been very exciting, and we get a lot of interaction from our students. Our students really love this project. They have a great time with it. Basically, what we're teaching is a process, a creative design process where they research, they design, and then they finally come up with a creative solution to a problem. Again, when they're done, they actually test their ideas. Okay, we don't just do it on paper. When we're finished, we test them, and this is a test right here.
Well, thank you, Mike. We sure appreciate your enthusiasm, and thanks for hosting us.
It's been a pleasure.
We're interviewing Brian Warren from Chippewa Middle School, and Brian hosted this event last year, and we are now having him involved in our information data center. And Brian, could you tell us what you're doing here and introduce the students that are helping you?
Absolutely. This is my math team. I have Robbie Casewell, Lewis. I have Corey Barnes, Andrew Ruppel, and Derek DeWitt. Now, after the cars race, the cards come over here with the time on it, and these guys change the time into feet per second and then into miles per hour, so we can actually use that. The kids can understand how fast their car goes. Once they do that, I log it onto a database, and we'll sort the cars by speed, by time in the database, and that'll come up with the places at the end of the competition.
More mathematics.
Absolutely. We want to include the math in the industrial tech.
All right. Thank you very much.
You're welcome.
Jim, we'd like to thank you for hosting our program today, and could you tell us a little bit about your involvement and the value that you see of this program?
Thank you. We're delighted that Fort Gratiot Middle School has had the opportunity to host the annual CO2 Car Challenge. Our students have been working very hard in preparation for this program, and I know that Mike Batchelor, the teacher, has put in a lot of extra time working with them. I've been in the classrooms periodically watching the students work on their designs, and I've been very impressed with the sophistication that's gone into the design of the cars. The students have certainly spent a lot of time researching their designs, looking for the very best in aerodynamics, using all of their information that's available to them. I've been impressed with the way that they've been able to integrate some of their other coursework and the knowledge in the areas of math and science, and developing their designs. Some of the designs are very traditional, and others are very unique. And I think it certainly gives students a chance to be creative, and we're delighted that they have this opportunity, and delighted that we've had a chance to host it this year.
Well, thank you, Jim. We look forward to having it again. I know that you're retiring, and we'd like to congratulate you on 30, how many? 38 wonderful years.
Thank you very much.
Thanks, James.
Bye.
One of the very special parts of this program is the number of students that are involved in very responsible positions. They help us with chauffeuring the cars back and forth from the display area, or pit area, if you will, to where they're actually going to race. It's very important that it be coordinated so that the right car number gets up to race, and that all the ribbons are appropriately placed. And we'd like to say thank you to all these students, and we'd like to have them introduce themselves.
I'm Crystal Baker, and I go to Fort Gratiot.
Sarah Levady, and I go to Fort Gratiot.
Andrew Babcock, and I go to Fort Gratiot.
Sarah Seeley, and I go to Fort Gratiot. Allison Porritt, and I go to Fort Gratiot. Heather Brown, and I go to Fort Gratiot.
Molly Tuttle, I go to Fort Gratiot.
Dan Bruno, and I go to Fort Gratiot.
An extra special thank you to all these students and many, many more that are participating. Thank you very much. Appreciate it.